Okay, look at now. This having a potential say 10 volt. It is the same potential will drop across this one, no? The potential across the bulb will be same. What about the current? Let the current I flow here. This will branch out. I1 and I2. There's a path. Current is similar to like water. There are two pipes are there. So definitely the pipe, the water flowing here will encounter a junction. So what will happen to the water? Will branch out, no? Similarly, the current will branch out here. This will be I1, this I2. So I want to replace this 2 by an equivalent resistor, that one. So let's come for I. So here what is I is equal to from here? E by R. What about applying potential Ohm's law across this? What is I1? I1 should be E by R1. I2 should be equal to E by R2. What all the potential drop generated across cell will be shared by these two. They are connected parallel, no? So here what is V? V is equal to E equal to VAB. So now let's apply. I is equal to I1 plus I2. What is I from this circuit? E by R. What is I1? E by R1, E by R2. So therefore the effective resistance is given by 1 by R1 plus 1 by R2. So the effective resistance will be less than the least value in this case. Let's go for power dissipation. What conditions will come for power dissipation? What is the power dissipation? P1 is equal to, you can write directly V square by R1. I can also write I square R1 or directly, okay, now I'll start with this formula. I1 square R1. So what is I1? I1 will be E by R1 whole square into R1 or E square by R1. What is the total power dissipated here? It should be equal to E square by R. Now, I'll add up these two, P1 plus P2. We'll see what do we get. E square by R1. What is 1 by R1? This should be equal to 1 by R. And what is E square by R should be equal to? E square by R should be equal to P, no? Okay, either you connect bulbs in series parallel. What is the total power generated by cell? The sum of powers dissipated across individual network. Whether you connect them series or parallel, what is the total power generated by a cell should be equal to sum of power dissipated across individual resistor. Or the always shall I put like this? Power what happened will be always additive. The total power generated by cell should be equal to sum of power dissipated across individual resistor, whether they are in series or parallel. Now let's do comparison. If R1 greater than R2, let me take the bulb concept. Say don't discuss separately the bulb concept. When you discuss series parallel, no, the same idea you put for this one. So this bulb is having resistance R1, this R2. And now let me put a condition R1 greater than R2. What about the power? Which bulb will have more brightness? Which will have more brightness?
P2 greater than P1.
Here, according to the concept, P1 is inversely proportional to R1. No? So P1 less than P2. So this will be more bright. The second bulb will have more brightness. So B2 greater than B1. If they are in series, the one which is having more resistance will have more brightness. Will I agree this condition? So there's one small idea is what we are going to carry that one. When bulbs, they are connected in series parallel, which will have more brightness. So if there's based on the series parallel, I have to compare. Now, sir, if there are many bulbs are there, then what I do is I'll calculate power across individual bulb. Then I'll compare their power. With that, I'll say that among all, which is having more brightness. So how to predict the brightness of a bulb? By knowing the power dissipated across the bulb. Getting the method? This one. So this is about the series and parallel conditions. Okay, let's go for some application part on this.